Hi, my name is Sam Norton, and my presentation today will be about magnetic compasses. So, the magnetic compass is a very useful tool when it comes to air travel, though the number of errors possible while using one make a complete understanding of a magnetic compass crucial. After learning about the usage of a compass, aircraft navigators should understand its importance, but also find it easier to use one during flight. There are many components and possible errors with the compasses, so gaining a total understanding of every aspect of it is extremely important. So, a magnetic compass is a device that gives pilots the direction that they are traveling. It's located on the top of the dash in the cockpit, and it provides the heading of the aircraft relative to the magnetic north. So, for how simple the concept of a compass is, it actually has a very intricate design. So it does not involve any big magnets, but rather two skinny parallel magnets. This is because a large magnet would move around too much due to inertia, and also a large magnet would have too big of its own flux field, and it would be affected by the magnetic objects moving around it. A very hard pivot point is used to mount each magnet. Its purpose is to give the magnets a point to be connected to that has as little friction as possible. This allows the magnets to swing freely and align with Earth's flux field. The pivot fits into a near friction-free jewel cup. The jewel cup is it's very hard in case of hard landings, fast taxi on rough surfaces, and quick maneuvers while flying. Um, all of these actions cause bounces and vibrations, and that causes the pivot to lose its sharpness. As this occurs, the compass loses reliability. So the compass card is a reader that gives the first letter of the direction you are going in, and it's usually mounted to a spring. Um, each direction is 90 degrees apart, while every 30 degrees is labeled. The last zero of each marking is taken off. So for example, 30 degrees is labeled as 3. Uh, the pilot reads the card from behind the compass, so the directions are printed on the opposite side of the card. This means when flying, the the west will be on the right side of the card, even though that's the east side of the plane. Uh, a lubber line is a line that corresponds to the longitudinal axis of the aircraft, and it's placed in front of the compass to assist the pilot with an accurate compass reading. So to keep the horizontal reference in the compass, the card, the magnets, and the floats hang below the pivot point. Um, If the plane is at a high latitude, the magnets will experience dip air, um, though they can't hang too low. Otherwise, the compass will swing too easily as um, on turns and acceleration. Um, to minimize the dip in magnets, compasses are filled with compass dampening and fluid uh, to meet the requirements needed for the conditions of the planes. The liquids used are usually acid-free kerosene and or silicone fluids. Um, to prevent overswing, vanes are used as a sort of sea anchor since the fluids move around in the compass, though holes are drilled in the vanes to allow fluid to pass through. Some compasses don't even have any fluid. Um, they're dampened by magnetic eddy current. These aren't always reliable though, because they have a higher flux field. The magnets can easily be disturbed by other cockpit devices. And to keep the gases from the compass fluid, baffles are put in. So to explain Earth a little bit, while everybody knows that Earth is the place we live, when it comes to compasses, Earth is a giant magnet. Most of the world is taught that magnets attract to the north and south poles, though this is actually untrue. Earth's magnetic axis moves slightly every year, making a flux field. Earth's giant version of a small magnet, and they move with it. This creates what is called a dip angle, which is the angle between Earth's horizontal plane and its flux fields. Not taking account of these dip angles is one of the biggest problems when it comes to using a compass while traveling in aircraft. So an example of using a magnetic compass is, so you would first refer to a map. The angle difference between true and magnetic depicted on maps is called variation. Isogonic lines are labeled either east for, or they're labeled either E for east or W for west. The middle line is labeled 0 and it's called the agonic line. So first you would draw a line from one airport to the next. Say you were to find that course is 310 degrees. You would then find the magnetic variation in the area. If the variation is east, then you would subtract that from the true heading. But if it was west, then you would add it. So say the variation is 10 degrees east. So east you would subtract. So 310 minus 10 is 300. Then to take account for the compass deviation, you would refer to the compass correction card. It might say for 300 degrees, steer 305 degrees. So then you would fly at 305 degrees to reach your destination. So there's two different types of compass errors. These can grow into really big problems for pilots. One type of compass error is static. Static error is the result of deviation. So an example of this is when a magnet from another device in the cockpit disturbs the compass. Compensators are put out on the runway to help pilots figure out directions for takeoffs and landings. If these were aligned wrong, this is a type of static error. The other type of compass error is dynamic error. This is when compasses can't keep their composure due to certain conditions. This is like when an aircraft is on a rough route, the compass will become shaky and unreliable. That's a type of dynamic error. A pilot's knowledge of the compass is crucial to safe and efficient navigation. All aspects from the components to understanding how to read it are important in air travel. I hope this presentation helped you understand more about how the magnetic compass works and how to use it. Thank you.